Hello there, KP the Math G, and as you can kind of see, I am sporting my KP the Math G shirt. I don't know if you can see that, but a student, well, students came up with the emblem, kind of a Superman type emblem, and they came up with KP the Math G. I came up with none of this, and so anyway. Some have even suggested that I wear like a top over this and then I just pull that back, see, maybe a zipper that can just easily unzip, or buttons can easily unbutton, pull that back and show my, stuff there. Okay, anyway. This time we are going to deal with some concepts from the textbook, from what the calculus teaches. This is more than likely going to be the BC part of it, but those of you who are in regular calculus, you will enjoy this. And even if you're not, even if you're an AB student, this is something that you might want to learn as well, because you might get into some other calculus later on, and this would be one of them. This is called partial fractions, and these are what we call integrating techniques. Obviously, some people would look at this and say, well, that's an LN problem. What's the problem with saying that? What's the problem with saying this is an LN problem? Yeah, you see that x squared right there? Yeah, if this were just 2x minus 8, this is an LN problem. Now, it's always dx over x to the 1. Okay, that's what we're really wanting. And so we cannot, and if we did this, think about this. We have to use some other method, because if we were to just let u be equal to x squared plus 2x minus 8, then what's du? Well, we know what du is. It's 2x plus 2 dx here, right? Alright, well, I don't see a 2x plus 2, I just see a 12 up here. Had this been a 2x plus 2 up here, then yeah, or just even x plus 1, if we factored out a 2 and got x plus 1 up here, well, yeah, we could do that and then say 1/2 du is equal to, well, dx here, x plus 1 dx. Now this would be alright if I had an x plus 1 up there, but we don't have that, and we can't just integrate by letting u be, we can't do u substitution here. Well, okay. Well, we have to come up with another method. It's called partial fractions. If you look carefully at this denominator, we can factor this denominator, can't we? Can we not say that this equals 12 over, well, okay, we're integrating. Alright, now, can't we not factor this? Alright. We know how to factor. X times x is x squared. The minus sign on the end means that this is positive times a negative. We hope it factors. If it doesn't, we got to do something else. Another way. Okay, 8 is what? 4 times 2? And the 4 needs to be positive and the 2 needs to be negative, because 4 minus 2 is 2, and 4 times negative 2 is negative 8. And I can write it like that, can't I? Well, what justice does that do if we don't have any kind of, well, let's put dx up here. Okay, now, okay. Well, what good does that do? Well, we got to come up with a technique here, and that's what we're going to do. We're going to say right here that this equals, let me try this other blue. I think one of the blues is streakier than the other. Maybe this one's not as streaky. let's say we have, let's just ignore this, okay, I know, I'm going to erase this for the time being. I just got it down, didn't I? Okay. Now remember what we factored. For the time being, without the integrand sign here, okay, the integral sign, I'm just going to say 12 over, okay, x squared plus 2x minus 8. We said that that's equal to, well, we just factored it. I'm sorry. We factored it just now. X plus 4, x minus 2. We want to do that. If we can possibly factor that, that's what we want. That's idea. Now, that's equal to, we could say this is equal to a, sum a, over, and we could pick either one of these two factors. Well, since x plus 4 is first, I'll do that. And then plus b over x minus 2. Now that's how the setup is done. Taking this without the integral sign here and just saying, well, this, we could do that, right? And to really make this equal, we have to get a common denominator. So this is what we're going to do. So if we had to solve this, and I want to solve it, eventually we need to find out what A is, and we got to find out what B is. And this is the idea. Just bear with me if you haven't seen this. If you have, well, it's good to review this. Okay. Let's see. If I were going to solve any kind of fraction like this, I have fractions involved. I want to multiply by the denominator, provided that x is not equal to negative 4 and x is not equal to 2. Right now, we want to get rid of this denominator. Okay, so let's do that. All right, so if I multiply this term by x plus 4 times x minus 2, and I multiply this term by x plus 4 times x minus 2, and then this term by x plus 4 times x minus 2, I notice I can start dividing out. Look here, this is gone and this is gone, so this side is 12. Okay, this is gone and this is gone. I'm left with a times x minus 2, and then here this is gone and this is gone, and I'm left with b times x plus 4. Now, there's a couple ways we can do this, okay? And I want to show you probably both ways. We may have to do two or three lessons on this, and then we'll get back to our free response questions that I've got at least 2 more lined up. Maybe 3 more lessons on that as well. But let's do this for the time being. Now, we could multiply this out, but I don't want to at this point. I'm going to show you, this is called method 1. Give me method 1. Okay. Now let's just take what we've got here, and what happens, what do you think would happen if x were 2? If this x is 2, then 2 minus 2 is 0. We want to create one of these needs to be 0. Alright, so for the time being, then this one, if we make this one 0 here the first time around, then the next time around we want to make this one 0. What would make this one 0? Yeah, you got it. Negative 4 plus 4 would make this 0. Alright, so let's do this. I'm going to say a 12 equals a times, let's make this one 2. So let's, first of all, we want one of these to be 0 so we can solve for the other one. Alright, so let's say right now, so first, let's let x be 2. I just told you the denominators can't be 0, but this is the way we have to work it out to make it work for us, okay? Alright, so 2 is x. So 2 minus 2 plus b, now x is 2, right? So 2 plus 4. Alright. This is 0, so 12 is equal to a times 0 plus b times 6. Now this is lengthy. This gets to be a little lengthy here. Let's go ahead and come up here with this. So 12 is equal to, this is 0. A times 0 is 0. So 6b, which means that b is equal to 2. 12 over 6 is 2. Alright, now remember we're going to need this when we start to integrate. I need this back. Alright, so what I'm saying is eventually I want to come up with a, which I already found this out to be 2, over x plus 4. See that x plus 4 that I just canceled out right there? Alright, dx. Now plus, now I'm going to have b, which I need to figure that out, over x minus 2. And all I need to do now is figure out, well, what is b now? We found a to be 2. Now we need to figure out, wait, was that b? b is 2. My goodness. What side of the bed did I get off on today? Okay. Well, my wife wouldn't tell me I got off on the wrong side of the bed. Anyway, sometimes she has asked me that. You get off on the wrong side of the bed today? No, not today. Okay, now let's see. Now let's let this be negative 4. Okay, so in this case, this time, second time around, let's let x be negative 4 this time. We just want to create a 0. Okay, now we want to find a. That's what we want right here. So we found b. That's good. That's an ln function, isn't it? Oh, it's going to be ln. Okay, let's see. If I were to erase this, come up with this. I just have to keep erasing, y'all, so excuse me. Alright, so this time we're going to let x be negative 4. Negative 4 minus 2 plus b times negative 4 plus 4. Okay, like that. This is going to be a times negative 6 plus b times 0. This time b is, the 0 is with the b, isn't it? So now we have this part right here. This is 0. Alright, so now 12 is equal to negative 6 times a. So if we divide both sides by negative 6, a is negative 2. So now I know what a is. A is negative 2. Alright, these are doable, aren't they? Right? These are very doable. It's not doable here unless we do what we call partial fractions. Okay? Let me show you another way that we could have found these numbers. Well,
with a forecasted high of 78 and a low of 44.
Oh, my wife had to ask Google about the temperature. Okay. Okay, so anyway. So if you heard something, that was Google answering what the temperature is going to be. Okay. Alright, now, well, I'll tell you what, let's go ahead and work these out, and then I'll show you the other method. Tell you what, let's do. I want to keep this here. As a matter of fact, let's erase some of it, and then I'll come back. I don't want to leave this undone. I want to leave this here, and I want to okay, I want to leave this up here like this. Okay, alright, and it doesn't matter. I don't guess it matters about that. We really just want this part right up here is what we want, but we do want to show what we did. Now it was 12 over, alright, we said this was a over x plus 4 plus b, always plus here. It may turn out to be minus someday, but right now it's plus. We always do that. Alright, and now we got this from all this when we multiplied through by. Okay, so alright, so I just want to kind of leave that here. Alright, so let's put this back up here and solve and see what we get now. Let's see, negative 2 over x plus 4, 2 over x minus 2. Negative 2 over x plus 4. So we're integrating. It was 12 over x squared plus 2x minus 8. And that was, what was the a? Negative 2 over x plus 4, right? And then plus 2 over x minus 2. And by the way, dx. Let me double check, because I don't want to be incorrect after I've done all this work. A over, okay, so negative 2 over x plus 4, 2 over x minus 2. Okay. Alright. Now, by the way, we could put this equals negative 2 on the outside, and now we have dx over x plus 4, and we could put this 2 on the outside here and make this dx over x minus 2. Okay. You really do not need to do substitution to this. If you already know that this is ln, you can do that. You have an x to the 1 power now, and that's in the denominator. This is automatically ln. We could just simply say 2 ln. Oops. Well, I do that every single time. 2 ln of x plus 4. And then we could say plus 2 ln absolute value x minus 2. And remember, there's no definite integral, so we do plus c. We could, look, we could let u be equal to this denominator, x plus 4, and du is equal to, well, this dx, right? Okay, so what we would have here is actually du over u, which is ln of u, but u is what? X plus 4 in the first place, isn't it? So when I see that, that's ln. And again, once again, folks, this, just seeing this right here, and I see a square here, that's not ln. I've got to do partial fractions and hope that this factors. And if it doesn't factor, we can still do it, but it has to be by another method, okay, which we will get into at another time, okay, and that's called by trigonometric substitution, which some of you may have heard of, okay, but this can be factored, okay. And we'll find some part that will not be factored. Now I said there will be two methods that I want to show. Here's the answer here. We've already got that, didn't we? This is negative 2 ln x plus 4, positive 2 x minus 2 plus c. We could do a little more work and bring that over, but this is good enough right here. This is plenty. That's all you really need here. And that's what you got. You're going to have this every single time. Now, if we took the derivative of this, we would come back to this. And I don't want to do that right now, but that would take up a little more time. But that's another time we could do that. If you want me to, give me a suggestion. Write a comment saying I'd like for you to take the derivative of this to show that we get this back. And that's what you really want, because if you don't get this back, all of this means absolutely nothing. We just came up with some kind of something. The mathematicians dreamed up something, and this is what we get. But just note that when you take the derivative, you're not going to get this back. That's wasted math. If you do that, that's useless. But when you take this derivative, you're supposed to get this back, and we do. I've already checked that out. But anyway, all right. Alright, that means that this is partial fractions. There must be a little something to that. Now let's do a method 2 here, and I'll show you that we will get this. If we were to just multiply this out, a times x, 2 times a, minus 2 times a. Now remember, a is like a constant. This is a coefficient here. This is a constant here, no coefficient. Yeah, so anyway, this represents one number, okay. Alright, bx, b is a coefficient here, and in this case 4b, b times 4, 4b. Alright, so the ax and bx go together. Alright, so ax plus bx go together, and then the negative 2a plus 4b, so negative 2a plus 4b. Alright, well, what's the significance of that? Well, we're going to set up a system of two equations, but this time we're going to leave the x off. We're just going to leave the coefficients there, and we're going to set that. Now remember, this was x, right? But there is no x on this left side. There's actually, well, there is no x. It's a 0x. There's no x. Well, we just put 0. So this part, the a plus b, to the x's is equal to 0. But this has a number here. What's that number? This is a number plus a number. Well, this equals 12, like that. And if we were to solve this by the elimination method, okay, we could multiply 2 times a, 2 times b, and 2 times 0, and we would get 2a plus 2b equals 0, and negative 2a plus 4b is equal to 12, and we notice that this is 0, and we get 6b is equal to 12, and then some of you might say, well, I did it that way. B is equal to 2. Okay, you can do that, okay? That's what I call method 2. That's the B part. And the A is done exactly the same way. Where are you, eraser? Alright, so if I were to multiply this by negative 4 right here, negative 4, negative 4, negative 4, then I would get negative 4a minus 4b is equal to 0, and negative 2a plus 4b is equal to 0, and notice that that goes away, and that's negative 6a is up 12 is 12, and then when I divide by negative 6, I get a is negative 2. So b was 2, b is 2, and a is negative 2, and then I just simply fill in for a. A was here, b is here. This is 2 ln's right there, and then I just simply take out the negative 2 and the 2 and just deal with that way. Alright, so that's I thought I would probably have 2 problems to do. This is probably one and enough, and probably quite a little bit to kind of let sink in a little bit, especially if this is the first time you've seen this, okay? But the general idea is to know that you cannot let let u be equal to this. You have to say, well, all right, let's divide it up if we can. Let's factor this and put a over this. We don't know what a is. We did find it to be negative 2, and put b over this, and we found it to be 2. And now we got the ln. We can easily do this, and voila. There are 2 other types we could look at, which we may do in the next couple of videos. This is the 99th video, so I imagine my 100th video will be dealing with partial fractions. 99 videos after this one here. I get every once in a while really good comments that they are very appreciative of me doing the job that I'm doing, and I really appreciate that. That really gives me a boost to think that I am making a difference here. That's what I'm here to do, is make a difference to you and help you understand this better, and all of this. And I always say that if you know a better way, then show me, but you need to be right. Okay, you better be right. And if you are, I will put yours up here. Hey, a student showed me this is a better method. But I mean, if you're pleased with what I'm doing here, yeah, I like comments, and I like those likes and subscribes. I'm getting more and more subscribers, a little bit at a time, but yeah, I'm enjoying that. It's very encouraging to me. But again, it's not all about me. It's about me helping you become a better calculus student and understand what in the world am I looking for, And I had that problem when I learned calculus. What am I finding here, Okay. And that comes with practice and practice and more practice, okay? And if you can get somebody to help you understand it quicker and better and easier, that's what I'm here for. It's not to my glory, but to yours. Anyway, this is KP the Math G signing off. I always end with a signature clap, which my wife said she was going to come in here one day and she was going to clap on my behalf, but I won't call her in here today. But maybe someday I'll get her in here and she'll clap us off. Well, anyway, KP the Math G signing off, ladies and gentlemen. Have a great, great day.